Well, hi everyone. In this video, I'm going to show you an example of how to prove that a particular graph does not have a Hamilton cycle. While I'm introducing the problem, you might want to start by writing out this graph. It's got a number of vertices and edges, and just enough to make this, not just a simple problem, but one that will rely on a number of things. We will have to use the symmetry of this graph. We will have to use the fact that there's cases that we can explore. And we'll look at those cases and try to rule out the existence of a Hamilton cycle in each of those cases. So the best way to show that the graph does not have a Hamilton cycle, if I was going to prove that, which I am right here, I'll start, is to go by way of contradiction. Okay? So by way of contradiction, assume that G has, we'll call this graph G, right? That it has a Hamilton cycle. I will just remind everybody what that means is that there is a closed path that visits every vertex of the graph exactly one time. That's what a Hamilton cycle is. We're going to assume that G has that, and then we're going to arrive at a contradiction. And we're going to use many of the tools that typically are used when talking about Hamilton cycles. One of those tools is that the Hamilton cycle, cannot have a premature subcycle. You can't have a subcycle that doesn't yet reach all of the vertices in the graph. From that simple observation alone, if we look at the four outer vertices that are all connected by edges, A to D to J to F and back to A again, not all four of those edges can be used by this Hamilton cycle. Because those four edges form a premature subcycle. I say premature because does not reach any of the vertices in the interior of that diamond on the outside. So we cannot use all four of those outer edges. Now, does that mean we have to do four cases? Suppose we don't use edge AD, and then what about AF and JF and JD? Do we have to do each of them? It turns out no. If you look at the symmetric nature of this graph, we can just freely assume, without loss of generality, any one of these edges to have been not a part of this Hamilton cycle. Now there may be several of those four edges that are not used by the Hamilton cycle, but at least one of them is not used. So I'm just going to say here, without loss of generality, suppose that AD is not in the Hamilton cycle. Okay? Now, while I'm going along here, guys, I'm going to be erasing edges that are not being used. Of course, you don't have to do that when you're writing this up. It's just so I can visualize it easier. And of course, if you write your graph in pencil, you could have a copy of it on the side where you're doing this erasing as well. Once I have deleted the edge AD, which is simply by way of, without loss of generality, I then see that some other things have to happen. Look at vertex A. There are only two other edges available. And because we have to visit vertex A, we would have to use both of the edges that are incident with A. I'm going to go ahead and shade those in now, highlight those, that we are going to use those edges. So then, we don't have to explain every single thing that we're writing down. We just want to try and do it in order. So AB and AF must be used. Okay? Now at this point I can't say anything else for sure. Like I don't have any other vertices where there's only two edges available to me. But if I look at vertex B right there, I can see that I'm either going to use BC or I'm going to use BK. And what I could hope to do is two cases and that's what I'm going to do. Case 1, where BC is used, and then in a little while I'll come back. Once I get I'm going to try to obtain a contradiction here. Once I've obtained a contradiction in case 1, I will come back to case 2, which would be that the other edge, which is BK, is used. Okay, so we're kind of going to break the proof into cases. This is what I was saying earlier. A graph that's this complicated, a proof by cases, might be needed. Once I'm done with case 1, I will need to return the graph back to exactly how it looks now so that I can then analyze it fresh for case 2. In case 1, I'm assuming that BC is used. I'm now going to proceed to sort of within this case make 2 columns, with one column being edges that must be used and another column with edges that can't be used. So we're going to just kind of methodically go through the reasoning here. If we must use BC, let's assume that BC is used. That sets off a chain reaction of other conclusions. First of all, I've now used 2 edges that are incident with B, so I'm going to not be using BK. Let me go ahead and erase that one, and I'm going to put that in the can't be used camp. BK or KB, whichever way I want to write it. Like I said, that sparks a chain reaction because now if we look at vertex K, I only have 2 edges left that I can use on vertex K, and I have to use both of them because I have to visit vertex K. So KE and KF must be used. I'm going to shade those in. All right. Feel free to pause the video if you want to think about it for yourself. You certainly can. It's just more of the same, really. We're just going to continue to progress through the graph towards a contradiction. Look at vertex F right now. I'm already using 2 of the edges that are going to F, which means I can't use any of the other edges that go to F. So that would be, what is it, FH and FJ. I can't use either of those. FJ is right here. I cannot use that edge. And FH is right here, and I cannot use that edge. All right. Let's see what that implies. Look at H and J, right? Both of those have only 2 remaining usable edges, and we have to use both of them. So EH and HI, let's write those down. EH must be used. HI must be used. And then also for the vertex J, IJ has to be used, must be used. And JD must be used. Wow. That's a lot of things that we've got so far. Now, on top of that, look at vertex I now. I've used 2 edges that go into vertex I, so that means that GI cannot be used. Let's put it in the can't be used pile. I cannot use GI, but now that means that now I'm really in trouble because I also cannot use, if you look at vertex E, I also cannot use EG. So EG is also not allowed. Actually, neither is EC, just for the record. I can't use EC either. And if we look at vertex C, I now actually have to use CD. You can see where we're going with this, right? I must use CD. And we have actually made a premature cycle. Notice that vertex G is not part of the cycle. So we have a premature cycle. And I think it's helpful to write down what that cycle is. Just anywhere you want to start here. I'll start with D up at the top. It goes to C. It also doesn't matter what direction you go. C goes to B, B goes to A goes to F goes to K K goes to E, which goes to H, which goes to I, which goes to J, which goes back to D. That is premature. It almost managed to reach all of the vertices in this graph. There's, I think, 11 vertices in this graph, and we managed to reach 10 of them. Exactly 10 of them. But that is a contradiction. That is, without a doubt, that is a contradiction. So with that in mind, I'm now going to so I'll just say contradiction in this case. But I need to take the graph back to where it was before we started this sort of snowball of conclusions that we had made. I might be best off just almost redrawing the whole thing, actually, because most of these edges have been filled in. So let's go back to where we were in the beginning. I've got my 4 outer edges sort of still here, right? And actually, we had decided not to use the edge AD, which forced us to use these 2 edges here. But then there's a lot more edges here in the center of the graph that I need to come back, and I need to put these back in. Let's see, we had 2 things here like this. Right, and then same thing on this side, 2 vertices here. I'll come back and label these in just a second. I just have to bring the graph back to how it was before we specialized into those 2 cases. Let me get the vertices labeled one more time. This one was C, this one is G, and I, and H is here. This one is E, this one is K. And I think that's everything. I think that's all the vertices. I'm now going to get a contradiction in case 2. And case 2 is where I am going to use the edge BK. It didn't work when we used the edge BC. So let's use the edge BK. It's the same kind of analysis again, right? Notice, for example, that I cannot use the edge KF because that would force a premature cycle, right? So I'm going to make 2 columns over here again, just like I did in case 1. I'm going to have a must be used column, right? And a can't be used column. And what we've just done is put KF in the can't be used pile, and I'll just put PC next to that. It's a premature cycle if we do that, okay? So I'm not going to use KF, but that actually means that I have to use KE, because that's the only remaining edge incident with vertex K. So I must use KE. I also cannot use BC because I've already used 2 edges that are incident with B, so I'll put BC in the can't be used pile. And looking now, again, pause the video if you want to do it for yourself. I'm just a little excited to show you. Now look at vertex C. There's only 2 edges still usable for vertex C, and I've got to therefore use them both. I must use CE, and I must use CD. All right, we're getting there, hopefully. Once I've used KE and CE, I cannot use anything else related to vertex E because we've used 2 of its edges already. So I have to erase EG and EH. So EG and EH both go into the can't be used pile. Now this has got to be a contradiction, doesn't it? Yeah, look at vertex G and H. Both of them only have 2 remaining usable edges, and so I've got to use both of them. And if I fill all of those in, I've already got a premature cycle. This time it's premature because it never made it over to vertex J, right? So in this case, well, let's add the vertices that we used right there. We used DG, GI, IH, and HF. We used all of those, and so now let me come back, and again, I think it's helpful to just, for the purposes of thoroughness here, write down what is the premature cycle that we have. Well, this time I'll start over at A, because it doesn't really matter. A goes to B, which goes to K, which goes to E, which goes to C, and then D, and then G, and then I, and then H, and then F, and finally back to A again. This is another example of a cycle that made it to 10 out of the 11 vertices, but it was still premature. It missed one of the vertices. Guys, that's it. Those are the only cases you can have. We just make an analysis of what edges must be used and can't be used in each case until we get a contradiction, which generally, I should point that out here too, which generally is that you create a premature cycle. In both of these cases, we came up with a premature cycle, and those premature cycles basically are what we need to get our contradiction. So we use a little bit of casework, a little bit of symmetry, and just the fact that every vertex has to be reached exactly once, which means that you have to use exactly 2 of the edges that are incident with each